LTE speed we all have calculated almost 303 megabits per second. Right. Which is going to go far up to 1 gigabits per second. Downlink 500 megabits per second as in uplink speed. Right. This is what is the next target for LTE. Another one, till in a case of LTE we was stick to 20 megahertz of band. Right. Now we have a new feature named as carrier aggregation, where we can put 5 bands of 20 megahertz. So when we are deploying 5 bands of 20 megahertz almost, so we can use 100 megahertz of bandwidth, through which we can expect to have this speeds of 1 gigabits per second and 500 Mbps respectively. Right. Another thing, as a requirement, we also have, so we have to reduce the latency. What we're discussing is a requirement for LTE Advanced now. So latency is something that was required to be reduced. So for user plane, for data, it should be less than 10 milliseconds over the air, and for control plane, it should be less than 100 milliseconds. Right. Another good thing here, we have to provide a high mobility. So the speeds which we are discussing should be able to retrieve, we should be able to retrieve good speed at 350 km per hour of speed as well. So even at the high mobility rate also, we should be able to get this speed. Right. Another new thing which we have introduced here, because of what the speed goes so high, is 8x8 MIMO. Multiple input, multiple output. Right. So on the thing, we have introduced some new spectrums here. We discussed in case of LTE we can go from 700 to till 3600, but now we have introduced some new frequency bands, 450, 470 megahertz as well, which can go till 4.2 gigahertz as well. Right. So we have increased some more frequency bands that can be used to deploy the LTE advanced network. Okay. And another thing we already know, we have, though it was already started with LTE, but advanced with LTE release 9, and with release 10 it is something quite advanced now. Though we also have release 11 and 12 and 13 in the market, but we are not going to discuss that. So this one features is self-organized network. Self-organized network is, it can do some of the features which we were going to discuss in the slides, is you organized the network self. Like you can do self-configuration. You can do some self-optimization. Right. So things like this, and another one, self-healing. I mean, you can save some of the things by yourself. So these three things can be done itself by the equipments. The features, the node you're using, they can do these things by their own selves. So you need not to have, the manual power could be decreased by using all these things. Another features now we have for LTE Advanced, the first one, like first we discussed previously, was the requirements. Now we have some features. Okay. So till here. Okay, so other thing which I was talking about here was carrier aggregation. This is something new, right? This is something what has been what is talking about now. Carrier aggregation, it is allow the multiple carrier frequencies to be mapped over the same site so that it can have the good throughput. Like in previous example, I told you 25 carriers of 20 megahertz each. Right. So this will increase the effective bandwidth, and also further it's going to increase the data rate. So now to calculate this 3 gigabits per 1 gigabits per second and 500 megabits per second, the process is still the same. Like, so technology OFDM is still the same. So 168 symbols per milliseconds. So 168 into 1000 symbols per second into 64 com modulation, there's 6 into the resource number of resource blocks, the bandwidth, right? So now we know for 20 it was 100, so for 5 it would be 500. Then you have no coding rate and number of resource block, modulation, symbols per second. The calculation, if I'm not missing something, resource block, modulation, carriers. Okay, so this, if I'm not missing something, this calculation is going to give you this result in downlink, this result in uplink. So what we have increased is the bandwidth. Oh yeah, MIMO. Sorry, how can I forget that? So another one, in case of LTE, we were discussing about 2x2 MIMO, and maximum we were discussing about 4x4 MIMO. That is 4 transmitters and 4 receivers to transmit the data. Now we have introduced 8x8 MIMO here as well. So I'm just going to add a single 8. So transmission and reception will be 8 times. Right? This is going to give you a good boost in the speed, in the data throughput for 4G, which is LTE advanced, which is the real standard for LTE, as compared to the another previous technologies for LTE also. So carrier aggregation is a new thing. It is something which will be new for planning. So you can use multiple carriers, which we call as carrier aggregation. Another one we have here, that is the source blocks. Okay. So we have 100 carriers, so 100 resource block. When we talked about 20 megahertz, we're having 5 now carriers of 20 megahertz, just giving us 500 resource blocks. Okay. Have is MIMO. We discussed already multiple times, so we have introduced 8x8 MIMO here. Let me write in the pointer here. Then we have another feature, self-organized network, that we have discussed, and we're going to discuss in detail what are the self-organized networks we have. Yeah, it's RV, resource blocks. Right. Then we have something called heterogeneous networks, HETnet. This is something good because this is something the world is moving around now. Have you heard this word earlier as well, like somewhere in the curriculum or somewhere else? We have a big site, and then also we have some small sites, just covering some small areas only, because this is a small site and this is a big site, right? So in this case, the big site is going to give the coverage and the capacity for the small cells, the small areas, this one, and this is going to further radiate and or retransmit the same signals which he has cached from the big cell. So what I am naming it here is a primary cell, P cell, and what I am naming these are the small cells. Right, so it's going to extend the coverage and it's also going to extend the capacity where it is required. So these small cells are just small areas, small cells which will be covering just a small location areas, a small areas responsible to get the coverage thereby and to allocate the data throughput. Because if no doubt, if you are near to the cell, if you are near to this particular tower, rather than getting coverage from this one, you will get it from this particular small cell or secondary cell, right? So in this case, definitely you are going to improve your own throughput. You're going to improve your own coverage. So these are basically small cells which has been covered by the macro cells, right? Okay, so they can be just 2 watt of power that is being used here, right? This is something the world is talking about now. So this type of things, this heterogeneous network or this small cell technology, can be used by any of the technologies. And this can be deployed with 3G as well. This can be deployed with GSM as well. Right?